Question 7. So we have the hydrocarbon D and E here. Part A, give the systematic name of E. Okay, so let's say this is the first carbon. So second carbon, third carbon, fourth, fifth, and sixth. So the first carbon, there is an ethyl group, and on the third carbon there is another ethyl group. So therefore it's 1,3. 1,3, 2-ethyl means di-ethyl. And this is benzene, bonded to benzene, so the name is 1,3-diethyl benzene. Okay, part B. So this is the proton NMR spectra of the D. So it has 3 signals, means around 1.3 to 4 and around 2.7 to 8. There is triplets and quartet, and this is actually this is multiplet, which is the protons in the benzene ring. Okay, but in this NMR it shows a singlet. This is alright. Now let's use the structure of the D to know which proton is formed the triplets, quartets, and this singlet. Okay, so the easiest one is here around 7 ppm. So all the hydrogens in the benzene here, it will give these signals. Okay, this one, this methyl group and this methyl group, actually they are equivalent, means they will give the same signal. So means we need to know their spin-spin coupling, and the splitting. So this one is one group. This proton is coupled with the neighboring proton. So these 2 protons. So it's 1 plus 2. So therefore it will give a triplet here around this 1.3 to 4. And this one, it will couple with S1, and it will couple with these 3 protons. So 1 plus 3. So this CH2, it will form quartet. Because this CH2 is next to benzene ring, so the chemical shift is slightly higher. So you can check the table for confirmation. So now we know the triplets quartet is from which proton. Again, this methyl group and this methyl group, they are equivalent, will form the same triplets. And this CH2 and this CH2, these 2, it will form this quartet. So if you understand this, then you can fill out the tables later. Okay, but before that, let's move on to this part 1. Suggest a suitable solvent for obtaining the spectrum in the figure 7.2. Solvent for the proton NMR, normally we use a deuterated solvent like the CdCl3. You guys just remember this, the solvent used in the proton NMR. Part 2. The proton's NMR of E is obtained twice. E again is this, E. So E actually it has no COOH, it has no OH, NH. It's just a normal hydrocarbon. So when this compound is shaped with the D2O, actually there is no proton exchange. So means the signal is still unchanged, because the OH bond, this NH bond is not there. So it will not really disappear. The signal will not disappear. So that's the answer. Because you say that the E is obtained, this proton NMR of E is obtained twice. Once before and once after shaking with D2O. And D2O is only used for OH and NH for the proton exchange. Since there is no OH and NH, therefore there will be no signal get disappear, right? So no difference, as the no protons that can be exchanged with the D, right? Part 3 is the one I told you just now. You just need to use the NMR just now to fill up this table 7.1. Okay, around 1.3, I told you already, there are 2 methyl group, so it's total 6 carbon. So methyl group, the groups that are responsible for this peak is methyl group, and there are 2 methyl group, therefore total 6 protons, and the splitting is a triplet. Okay. For the second signal is the 2 CH2 there, total 4 proton. Okay, and of course the group that responsible is CH2, so CH2 times 2 you get 4 hydrogen here, or 4 proton. The splitting is quartet, I already told you just now. Okay, the number of protons for this 7.1, it must be for the benzene, right? It's total 4. I told you just now. Okay, you can check the table if you want. Okay, now part 4. Compounds D and E can be distinguished by the carbon 13 NMR. State the numbers of peaks in each spectrum. Okay, let's start from the D. Actually, this is a symmetric molecule. You can draw a line here, okay, so to show the symmetrical properties of this D. Now means if now we want to get the signals, so the first signal, let's say, is from here. Okay, these 2 carbon 1 signal, second signal, okay, third signal, 4 and 5. So means for D, total it will form 5 signals. And for the E, you can draw, let's say, one line here, because it's symmetric. So let's start from here, the CH3. CH3, these 2 will form 1 signal. Okay, this CH2, right? This carbon, second signal. Okay, this one is the third signal. 4, 5, and 6. So for the E is it will produce 6 signal. The D only 5. So you just put in there 5, 6. Okay, part C. Compound D can be oxidized to form compound F. This one, the ethyl group now is oxidized to the COOH. So then we should use this oxidizing agent. Okay, which is the alkaline KMnO4, and after that followed by the dilute acid, because we want to form back the COOH there. You need to undergo acidification. Okay, so now write an equations for this reaction. Use molecular formulas only. For the D, then you can give the this molecular formula. Just count the carbon number. Total 6 plus 4 here. So it's C4, H14. So here total is 10. Okay, here is 4, so it's C10H4. And because it's get oxidized, then you just put the oxygen with square bracket. And the product, you just count how many carbon, total 8 carbon also. Hydrogen is 1, 2, 3, 4, 5, 6. So 6 hydrogen, oxygen is total 4. And because the side chain here, this ethyl group, one of the carbons and the hydrogens is being oxidized. So you must put CO2 and H2O. After that, you just balance the carbon number, because it's from the 10 carbons now form these 8 carbons compound, so it will release 2 carbon, and this carbon being oxidized to form the carbon dioxide, and of course the hydrogen also, it will form this H2O. Then you just balance accordingly. At the end, you get 12 oxygens needed here. Okay, part 2. Okay, the F reacts with excess SOCl2 to form compound G. The molecular formula of G is this one, C8H4Cl2O2. Okay, so this one is quite straightforward, quite easy, because it's this dicarboxylic acid. The OH group, it will be substituted by the chlorine once we use the SOCl2. This is what you learned in organic chem. So we can form the acyl chloride using the SOCl2, or we can use the PCl5. But in this question, I already say SOCl2, so we just follow. Means the dicarboxylic acid now, it will form this diacyl chloride. So you just draw these structures to this box, right, to show the This is a G. And for the J and K, then you have to be careful, because I already say that the J, the G means this one, the diacyl correct, reacts with ethane 1,2-diol. Then you need to know the ethane 1,2-diol, how it looks like. Means this one. The OH is at the terminals. So 2 carbons, ethane 1,2-diol. And the G will react with this ethane 1,2-diol to form J. J now it has a molecular formula C10H8O4. Okay, by comparing the carbon number, so you should know how many of them reacts. Okay, the G itself is 8 carbon. The ethane 1,2-diol is 2 carbon. Total is 10 carbon. So we know that it must be 1 G and 1 ethane 1,2-diol reacts. For the K, molecular formula is much larger, so it's C18. C18, you should know how many G will react with this ethane 1,2-diol. Because the G itself again is 8 carbon, so 18 carbon means roughly is we need to use 2G. 2G then is 16 carbon. Then plus the ethane 1,2-diol, then is 2 carbon. So from here, the molecular formula, we can roughly predict how many G and how many the ethane 1,2-diol is reacted. Okay, so means the J must be like this. Okay, 1 G means the diacyl correct react with ethane 1,2-diol. Okay, something like this. The ethane 1,2-diol, the 2 alcohol group will react with the acyl correct. Okay, HCl will remove here, and the new bonds will form. CO bonds will form. So it will form this ester bond. Okay, diester bond. So this one also will form the same thing. HCl remove, CO bonds form. So it will form diester, and it's a cyclic. This is a structure. For the K, I told you just now, because it's 18 carbon, so it must be 2G, because 1G is 8 carbon. So 8 carbon, so 2 times 8 carbon means 16 carbon. Ethane 1,2-diol is 2 carbon. So total is 18 carbon. So this is idea. Of course, you no need to draw this one. You just need to draw this product. I show you how the formations of products only. Like just now the J, you no need to show this one. You only show this, the cyclic. Okay, so if let's say now we have a ethane 1,2-diol with 2G, so it should react in this way. One terminals will react with the 1 acyl chloride in the G, right? Then it will form the new bonds here, the CO bond. And the other terminals will react with the this acyl chloride in another G, right? So again, HCl remove, CO bonds form, right? So eventually, it will form this compound. So you just need to draw this compound. So 2G with 1 ethane 1,2-diol. Okay, that's all. Thank you.